So when it comes to like actually solving the equations, we're not going to change anything today. We're going to do exactly what we've been doing, but now we're going to have different outcomes. All right, so there's 3 possible outcomes for the number of solutions we have. Now, solution, as we're used to seeing, is like x equals 3 or x equals -4, right? These are solutions. They're numbers that when plugged into an equation produce a true statement. If I have x plus 2 equals 4, what's my value of x going to be for that equation? 1? 2, right? If I plug in a 2, what do I get? Well, I get 4 equals 4. Is 4 equal to 4? Yeah, so that is true. All right? So all the equations that we've seen up to this point have only had one single solution. One number that when plugged in gives you this true statement. So the first outcome we could have is one solution. Now, this is the most common. Like I said, it's what we've seen this whole time is one solution problems. We know that we have one solution when we end our equation process with letter equals number. Even if that number is negative, even if that number is a fraction, even if that number is 0, if we have letter equals number, our answer is one solution, or our outcome is one solution. If we look at this equation here that it's given us, what's the first thing we want to do to this equation? It's a nice, easy three steps, I think. What's the minus 2x? Yeah, we're going to bring the variable to the left. Those two cancel out. I'm left with 2x plus 2 equals -4. What do I want to do now? -2, yeah, good. Thank you guys. -2. Now my 2's cancel out, and I get 2x equals -6. I'm going to bring this up here. Last step is divide by 2. And what's -6 over 2? -6 divided by +2? -3. Great job. And this is the kind of answer that we're used to seeing. Letter equals number. X equals -3. That means I have one solution. The only answer to this problem is -3. It's my only possible answer. But it might not always turn out this way. Just because that's all we've seen up to this point doesn't mean it's our only possible outcome. We might also see outcome number 2, which is many solutions. Many solutions. That means there's many numbers we could plug in for x and get a true statement like we saw right here. There's many different solutions. So this outcome, we know we have this outcome when we end up with a true statement. Basically, when we have a number equals itself. Number equals itself. It's a little bit confusing, but we'll see what that means here with this example. What's the first thing I need to do in this second example here? Starts with a D. Divide. Great guess. Even before we divide, what am I going to do with this outside 3? What do the parentheses tell me I need to do? No one knows? Like I said, that's a good guess. Not divide. What do we do when we see a number outside the parentheses? What do we do there? We multiply it, right? And it's called distributing. Must have been a long weekend. Distribute that 3 to the x and to the 1. 3 times x gives me 3x. 3 times 1 gives me 3. Okay, so I distributed my 3, multiplied that outside 3 by the inside x, multiplied that outside 3 by the inside 1. That gives me 3x plus 3. Right away, do you notice anything interesting about this equation now? No? Okay. What do we want to do from here? We want to bring the variable term over to the left. Right? So this 3x here, I'm going to bring it over to the left. What's the opposite of a positive 3x? Negative 3x. So I'll subtract it from both sides. What happens to my 3x's here on the right? Cross them out. Thank you. But what now happens to my 3x's on the left? We subtract them, but what's 3x's minus 3x's? 0. Nothing. Good morning. They cancel out completely. The 3x's go away. What's the only thing we have now on the left side of my equation? 3. And what's the only thing I have on the right side? 3. Is 3 equal to 3?
Yes.
Yes. This is a true statement. So my answer here is many solutions. Number equals itself. If we end up with something like 3 equals 3, like we said, that is a true statement. And if I have a true statement, I have many, many, many solutions to this equation. In fact, I have infinitely many solutions. Which means any number we plug in for x, we plug in for x, we can plug in anything. Negative 1,000,000, 1/2. We work it out, we'll get a true statement. Okay? Because the left side is the same exact equation as the right side. 3x plus 3 equals 3x plus 3. So when you see that, right away you know there's infinitely many solutions. There's not just going to be one solution like we had above. There's going to be many. All right? Any questions on kind of how we can determine if there's many solutions? You just work it out until you get number equals itself. Just like that. Now, the third possible outcome could have one solution, you could have a bunch of solutions, or you could have no solutions at all. No solutions at all. So we know we have no solutions when we end up with a false statement. Okay? Well, what does a false statement look like? What does a false statement look like? It looks like a number equaling a different number. Take a look at this red equation right here. Is 3 equal to negative 4? No. That is a false statement. Number equals different number. Is 2 equal to 0? Are 2 and 0 the same thing?
No.
No. So if we go through our solving process and we end up with something like 2 equals 0, there are no solutions to this equation. That means there's not a single number we could plug in for x and get a true statement out of it. So let's see if we could tell when that's, or when we have a situation like that. Just like in the last one, take a look. I've got a 4 outside my parentheses. What do I want to do with that 4? What did we say that we did? Multiply, exactly, and distribute. We distribute the 4 to the 2x. We distribute the 4 to the negative 2. All right? What is 4 times 2x?
8x.
8x, nice. What's 4 times negative 2?
8.
Nice. Great job. And then my right side stays the same. Just like before, what do I want to do now if I want to solve this for x? Minus 8x. We're going to subtract my variable term over to the left. If we subtract 8x over here and subtract 8x over there, what happens to my 8x's on the right? They cancel. But what happens to my 8x's on the left? They cancel out as well. What's the only thing I'm left with on the left-hand side now? Only thing left is negative 8. What's the only thing left on the right-hand side? Positive 5. Is negative 8 equal to negative 5? Are those the same number?
No.
No. My answer then is no solution. I ended up with a false statement. Number equals a different number. Negative 8 equals 5. That is not true. So there's nothing you could plug into this equation that will give you a true statement. It's like a broken, think about like a broken microwave, right? If your microwave doesn't work, you could put any type of food in it and it's not going to heat it up because it doesn't work. That's what this equation is here. Any little number we plug in will not give us something true at the end of it. With many solutions, you could plug in anything. Any number you plug in, you get a true statement. With one solution, there's only one specific number you could plug in to get a true statement. X equals whatever that one solution is. So those are the 3 different outcomes. You could have one answer, many answers, or no answers at all. All right? I'm going to leave the bottom up there while I get the second piece passed out so you can glue it in. Here it comes. Just 3 quick little examples to get some practice. Morning. How's it going? Good. Okay. You guys can sit at that back group, the desk group over there. Once you get this glued in, give this first example a try on your own. See if you can figure out whether you have one solution, many solutions, or no solutions. Yes. They're all out? Okay. Thank you. Nice. Great job. What do you do? No solution? I would take another look at the first one. Nice. You know the first one? No. What you gave them? Good. Okay. I see a couple people with the right answer. Let's take a look. At number one. What's the first thing I need to do with number one? Distribute. Thank you, sir. We're going to distribute the 2. Are we going to distribute it to this plus 2x over here? Do I want to multiply that 2 by the 2x, guys?
No.
No, why not?
It's not important.
Not in the parentheses. Great job. So we're going to leave that 2x alone. We're also going to distribute that 8 on the right-hand side. So what do we get? We get 2 times 3x. What's 2 times 3x? 2 times 3x would be what? 2 times 3x is 6x. 2 times negative 4 is negative 8. Plus 2x. And then the right-hand side, we multiply the 8. 8 times x gives me 8x. 8 times negative 1 gives me negative 8. Is there any like terms I can combine now? Any like terms on the same side?
6x and 2x.
Perfect. We're going to combine 6x plus 2x to give me 8x minus 8. And look at this. I can already tell what my answer is going to be because I've got the same expression on the left that I have on the right. What we're going to do now is subtract that variable term over. Minus 8x minus 8x. And just like we saw before, all my 8x's cancel out, leaving me with negative 8 equals negative 8. Is negative 8 equal to negative 8? Is that true? Yeah. So my answer is many solutions. Now my answer is not x equals negative 8, right? My answer is every number possible. Many solutions. That's what that means. There's every single number that we could think of, we could plug it in for x and get a true statement just like this. So the answer is not negative 8. It is many solutions. All right. Now, example number 2, same kind of deal. We're going to start with distributing. If I distribute the 7, 3x plus 4x minus 3 equals 7x minus 21. I'm going to combine these like terms right here. 7x minus 3 equals 7x minus 21. Now right away, we're still going to do our next step, but if you see the same variable term with different constants, you know your answer is going to be no solution. Because now we're going to subtract the 7x. They're all going to cancel out, and we're just left with those two different constants. Negative 3 equals negative 21. Are those the same number?
No.
No. So what's my answer going to be?
No solution.
No solution. Great job. If you get a false statement like this, negative 3 equals negative 21, that is not true. There is no solution. That's my answer. For my third example, I'm going to double distribute on the left and on the right. I get 10x minus 5 equals 12x minus 15. I'm going to subtract my variable term over to the left. What does 10x minus 12x give me? What's 10 minus 12? Negative 2x. Great job. Thank you, Princess. Negative 2x. I'm going to bring my constant term over to the right by adding 5. Thank you, guys. What's negative 15 plus 5? Negative 10. Good. No solution. I still got an x, right? So now I'm just solving it like normal. None of my variable terms canceled out. So this is just a normal problem that we're used to seeing. My negative 2's go away. X equals 5. How many solutions is x equals 5? 1. So the only thing different about these types of problems is now we're also including the phrase one solution on our answer. Okay? X equals 5, number equals letter, that is one solution only. Sound good?
Yes.
Cool.